Okay, so good evening again, and hello and welcome to this live Zoom webinar on data careers. So we're going to be looking today at data roles in the industry and the startups. And it's a special edition again, as we have with us tonight a senior data engineer, Ellen König. Hello, good evening, Ellen. And co-hosting with me as last time is Dania Mera. Hello, Dania, good evening. And the way this is going to run is I'm going to do a bit of an introduction for you, run you quickly also into the program, so to speak. And then I'm going to hand over to Dania and Ellen as the experts who are going to, deep dive for you on the data roles, and then are also happy to take your questions and answer them. So to get us started, I probably this is my favorite quote at the moment. I have to admit. I hope you like it too while you're looking at it. So the guy that I'm citing here, Jean-François Garnier, is actually he's a serial entrepreneur. He's a startup founder, has been over the past years, but he's at the moment most well known for being the co-founder of Element AI. Of which another co-founder goes by the name of Joshua Benjo, so a rather well-known deep learning expert. They're based out of Canada. They have sort of done some research on what they think is the expert or talent pool in AI. And if you look at this, the data is a bit older, and they've updated it over time. But if you look at it, what I want you to look at is on the left side, you see 22K worldwide and 5K worldwide. So they were trying to get at how many people there are. They used LinkedIn, they used conferences, they did some further research, and they also tried to gauge how many open positions there are, and they came up with a number of 30,000. Perhaps they're underestimating a bit, but others have checked, like the New York Times. So we're looking at a pool of 30, 40, or 50,000 people. And to my mind, and perhaps Dania and Ellen will agree, this is a relatively small number, and this is where this quote comes from. So the point here is why we're also running the webinar and why we're looking at data roles. It's early days. In many ways, it's early days. And therefore, this comment here that no matter who you are, self-improvement is one of the most important and perhaps also still most overlooked attributes of young talent, and it only takes 4 years of experience to become a senior. And then the other thing is actually that you have to, of course, have the determination to improve. And then the other part of the quote is that you need the technical skills, but also sort of soft skills or business skills. And this is the context in which we are looking at this tonight and running this event for you to look at this. So I mentioned Dania. Please, Dania, say a few words about yourself so that everybody gets to know you.
Hi, good evening, everyone. So I'm Dania. I'm a founding member of the AI Guild, and I'm working as a data scientist since 2015 here in Berlin, but I started earlier in 2012 as a marketing analyst. Currently, I am working focused on machine learning models for predictive analytics, especially time series. And I was also a bootcamp teacher until quite a few months ago.
Thank you, Dania. Ellen, over to you.
Yeah, so I currently work as a data engineer at the consulting company called ThoughtWorks. I have around 10 years worth of work experience in all sorts of things between data engineering, data science, and software engineering. And I've worked in industry, in consulting and startups, and in nonprofits.
Thank you, Ellen. So I noticed it's kind of well-rounded. So you have the experience with the engineering and the data science. Any particular reason why you switched from science to engineering?
Yeah, because I started in engineering and I kind of returned to engineering. It's probably not the right arc. Okay. I switched from engineering to data science because I got really into statistics. I was really interested in that topic, and I wanted to try out machine learning as well. But then I realized that I really care more, and I have a slide about this where I'm talking about this later. I really care more about the engineering parts of making the code nice and making the systems reliable, and less about the experimentation and the trying out model building part.
Understood. So the data science was actually an interplay in between software engineering and data engineering. And for you, the reliability of systems is really important, yeah?
Yes, that's super important to me.
Okay, thank you, Ellen. And then a few words of about myself. So like Dania, I'm also a founding member of the AI Guild. Something that I've been doing over the past years is running a campaign called 10,000 Data Scientists for Europe, which is particularly geared towards finding talent for the field. I also have a history with boot camping, so with helping talents find a first role. And through that, overall, I've been engaged in data career coaching for quite a while. Okay, so onto the program for tonight. In the meantime, let me repeat, if you have questions, also now, if you have questions to Dania or Ellen about what they do and why they do what they do and so on, please do. Stick them in the chat, that's absolutely all right. We will endeavor to answer all of them. So what you're getting tonight is I'm going to give you a quick overview over where this program comes from in terms of AI Guild career coaching. This is where this emerged from. Then we're going to look, number 2, at data roles specialization. Then number 3, we're going to look at what is called here data roles upgrading, but you could also consider it as a deep dive. So we're going to dive deeper into the various roles that there are. And then if there's any sort of time left at the end, I will come back and try and round it off with a few slides on orientation towards what's going on the market at the moment. I can see, of course, the list of participants. At the moment, we're at 29. Some of you are AI Guild members, I can see that, but for those who are not, the AI Guild is a go-to community for practitioners accelerating AI adoption. So it mainly consists of people that are active in data roles or perhaps on the product or business side of this. And the point is that they are all practitioners, so they do this actively and on a daily basis. We got going about a year or a year and a half ago, and we've been offering AI Guild career coaching for its members. So it's been running for the juniors and the seniors. It runs monthly or ran monthly. As you know, we've all moved from seeing each other to seeing each other online. So we're in the process also of reinventing these processes, but we've had a quite considerable coaching capacity already, and actually we're looking to build on that and make it larger. There are some things that we've noticed in running it. So in terms of insights from the career coaching that we've seen, I would like to point out that we've noticed that the search for a first as well as second role can actually be quite lengthy. And of course, given that we are at the moment in the middle of the corona pandemic and the labor market, particularly in Europe, is a bit more frozen and is in a way reverted to a buyer's market, if you so like, I would expect that search to perhaps even take longer. We've also noticed that other than searching, that upgrading inside a company might be easier. We've noticed that job advertisements sometimes can be confusing in the sense that the company is perhaps advertising for a unicorn or trying to fish with a very wide net. So this sometimes is not too helpful. And particularly something that I have also noticed and that concerns me greatly actually is that the role in real life may not actually be what is expected, and it might be a mismatch of expectations on both sides. Perhaps we'll get to talk more about this from the perspectives of the people that get hired. It's in the sense, some of my favorite quotes are, so I got hired as a data scientist, and now all I'm doing is I'm writing SQL queries, yeah, or I got hired as a data scientist. Now it turns out we don't have any data. So there are issues around there that with the job advertisement and the expectations that are interesting to look at. And if you've had experiences around this or have questions to this, we have 2 people here tonight that would be competent to answer those. So if you would like to ask or share experiences or something like this, please do so using the chat. And then a final round of observations on the market. So something that we've also noticed over the past 2 to 3 years is that we think that the specialization and differentiation is increasing. And this is directly also why we're doing this type of live show tonight, looking at the data roles. And with it comes perhaps also a rising value of domain expertise. So I noticed while working for a bootcamp that you know, you could really cross over. So if you were a biologist that worked in image processing, you could move straight to automotive, because it was really early days and the connector was the image processing. I think this is less likely now to happen, and there's more the question of what you already have and bring in terms of the domain knowledge that you have. I think that matters. Something else another combination that we are seeing, I think, is that in industry, but perhaps also in startups, this experimental phase with proof of concept after proof of concept after proof of concept is kind of coming to an end, and there is now an increasing focus on deployment, or at least that's the question that's being asked. You know, how do we get the thing into production? How do we make it work and stick? And how do we create value with that for the customers, for the company? So kind of changes, and perhaps good changes, because they show that the field is advancing. So, so much for my introductory round. We would now like to move into the data roles, and I'm going to hand over the microphone to Dania, who will then also bring on board Ellen. So Dania, all yours.
Thanks, Chris. So I would like to start showing you this image here on the left side, which is taken from a paper published by Google. And it is about all the pieces that have to come together when we are productionizing machine learning. So directly connected to the last thing that Chris mentioned, is not about experimenting and creating a proof of concept, but really about deploying the solution. And you can see there are many different pieces of this puzzle. So I try to differentiate what pieces would be a responsibility for which roles. So because data science is really a team sport, and the more people the different roles can collaborate meaningfully, the better the final solution will be. So what we see here, for example, in blue is the data engineering tasks, in gray, the machine learning engineering, in yellow, the data analyst, in red, the data scientist, and in green, the AI researcher. One comment there, the AI researcher here in green is assigned to the machine learning models. So let's say the central part of the machine learning solution being deployed. And this is because if we go to the next slide, please, Chris. Yes. So here I'm trying to also delimitate what would be the specific tasks for each role and the specific skills for each role. So I will start with the AI researcher, the green one, that was mainly focused on the machine learning piece of the puzzle from the previous picture. So the task here is really about building new machine learning algorithms and finding custom scientific solutions. So that is really focused on the state of the art and developing new solutions or custom solutions. And the skill set is mostly focused on research, presenting at conferences, and writing publications. When it is about deploying this solution in a business case, then this would be more of a task of the data scientist. So then it's the red part. The task consists of understanding the business case, building the features for the model, and then training the predictive models to address such use cases. The skills are mainly statistics, SQL, programming in Python or in R, and of course, understanding the machine learning and deep learning techniques. Together with the data scientists, we have in yellow the data analyst. So the task of the data analyst is, it goes together with the data scientist in a sense that there's also the business understanding and the data understanding, but the data analyst is more on the reporting side of things instead of the predictive side of things. The data analyst also has a skill set SQL and statistics, but focusing more on descriptive analytics, dashboarding, and visualization tools. Here, the communication skills are very important also to be able to report and explain what happens, basically telling the story with the data. And to support those two, what we have in the team, two engineering roles. One is the data engineer, which Ellen will talk more about in details, also from her first-hand experience. But this is maybe before the data scientists and data analysts come into play, because it's about having the data. So building and maintaining an infrastructure of a pipeline to collect, clean, and pre-process the data, which will be used for dashboarding or for machine learning. Here, the skills are more focused on engineering, so distributed systems, databases, software engineering best practices. And the last one is the machine learning engineer, because that's the last part. So let's say after the data scientist has trained a model, when we want to deploy and maintain this model in production, this is done with the support of the machine learning engineer. And then the skills are software engineering, DevOps, and systems architecture also. So the idea here is to show what it would be the specific roles, 100% focused on those tasks. We know that in reality, sometimes one person takes care of more than one of those roles, or sometimes there is a mix between them. But to explain it more complete, it would be better to go to the next slide, please. With an analogy. So if we think about cooking the data, so bringing this all of machine learning, making machine learning to production to a situation in the kitchen when we are cooking, we can think about data collection, data quality, and data processing. So the blue pieces of the data engineer, those would be like sewing, harvesting, and preparing ingredients for a recipe. Then comes the data analyst, or the yellow pieces. For example, doing some analysis and descriptive analysis on the data would be kind of like choosing a recipe. Then with the red parts for the data scientist, so feature extraction would be like using utensils, for example, like a blender to prepare the ingredients for the recipe. And then also configuring the parameters of the machine learning model would be like trying different combinations of appliances and recipes. And training the machine learning model, which is here in green, would be really like preparing, putting every ingredient together and preparing this recipe. After you have your dish ready, cooked, first, what you would do before serving this dish, it would be some sort of offline validation, which is here also in red as the data scientist task. It's like the kitchen tasting. So you taste it before you send it to the customers if you're thinking about the restaurant. And the last one, the A/B testing, it would be really the customer's tasting. So when you serve the dish to your customers, and they will tell you if they like it or not. And this all happens in the same base infrastructure. So here we can see in horizontal at the bottom, the infrastructure in gray, which is part of the machine learning engineer task. This would be the kitchen space and all the available appliances that we have to prepare the ingredients and to cook. Can we go please to the next slide, Chris? Yes, so this is a summary. We start with the data engineer to process the ingredients at scale. Then we have, not the best order, sorry. Then we jump to the data analyst in yellow to check the quality of those ingredients and match that with the recipes. Next comes the data scientist that will create and use the recipes to cook. In parallel, we have the AI researcher, which here would be someone that is building the kitchen appliances. So that is building, for example, a microwave or an oven that will be available for the data scientist to cook. And last, we have the machine learning engineer that will take this recipe, cook it once by the data scientist, and turn into many dishes that can be served efficiently in a restaurant when you think about having a high load of customers coming in. Yes, that was it. Thank
Thank you, Dania. There's a question that came in for you
Yes.
that I suggest we address. It's about the vastness of data science and whether you and perhaps also Ellen can comment on the vastness of the field and how to handle that. And while you actually answer the question, I would like to run a little poll in the background that, dear participants, we're going to ask you to fill in. It's anonymously, but it gives you an idea a bit more of where you're coming from and will help Dania and Ellen as they move forward. So off you go, Dania.
So let me check the question here from Ugulu.
Ugulu. Yes.
Yes, I hope I'm pronouncing it correctly. I'm kind of new to the area and I'd like to ask you something. I've talked with a couple of data scientists and all of them were doing totally different kind of jobs. I know that the job that you do depends on the company you work for. Yes, right. But we can say that data science is a massive area to work. I'd like to hear your opinions. So I would invite Ellen also to give her opinion. But I agree that it depends on the company you work for, because as I described it on the slides, the role of the data scientist, the way I understand it, is really to understand the business case and be able to use the data that is available and taking your knowledge of the machine learning or deep learning techniques to solve or to address those business challenges. So it really depends on the company, not because it depends on the industry, and then you have different types of data which will match with different algorithms, but also because you are addressing different needs.
Yeah, I would agree with Dania. So there's also a bit of a history to this term. So originally, all these kind of roles that Dania just mentioned, all these 5 different roles, they were kind of lumped together under data science. And some companies still haven't really sorted them out into different roles. So in some companies, data science still is the only person maybe working with data at all in the company. And because data science is the most well-known and also maybe the most fashionable term of those, a lot of things are labeled data science that may not necessarily be data science in the classification that Dania mentioned them. So it can be all sorts of things. And especially historically, as you've seen maybe in my career, people used to cross over between those roles pretty frequently. And so it's not as clear-cut as we might like it to be.
Yes, yes, that's true. Again, I presented the specialist roles because this is where we see the area of data evolving. But yeah, historically it hasn't been like this. And to this day, I don't think all the teams are split like that. Or even when you're looking for jobs, maybe you don't see all the 5 distinct descriptions or titles, but you would see a mix of them all.
Okay, there's another question that's come in the meantime for Ellen. An undergraduate computer science student by the name of Chukwudi would like to know what he could do to become a data engineer. Probably best and fastest.
So you're in a really good position if you're in computer science right now, because you can still take all the classes that are hard to take afterwards. So there's a lot of technology that's usually used in data engineering, like databases and distributed systems. So make sure that you take those classes if they're offered in your uni. And also software engineering is super important. So I would advise to focus on those 2 areas, the fundamentals of software engineering, how to build reliable systems, how to build clean and well-architected systems, and then also take all the distributed systems and database classes you can find. That will be really helpful. And if there's specializations for data science, for data engineering, like say streaming data or cloud infrastructure, or these kind of things, then those are also really valuable.
Okay, and we have yet another one coming in from Vladimir, who is asking about whether a job is restricted to one of the roles. And then he says he assumes that in a startup of 10 employees, this is not the case. So would you recommend to specialize in the role or have a broader but shallower set of skills?
Yeah, I can confirm that in a startup, mostly it's not the case, at least also it's not my experience. But I think that especially in the beginning, what you want to do is to have the broader understanding of the different roles and the different tasks, at least so that you can also experience them firsthand, and then you will get to understand where you want to specialize.
Exactly.
I don't know if you have,
sorry,
Ellen?
Yeah, exactly what Ania said. I actually have a slide about this later somewhere in the presentation, where I did a survey amongst other data scientists, what they recommend to exactly this question. But the idea is really to start broad and then narrow down into what you find the most interesting. Because in the beginning, you probably don't have a clear idea, and it's also helpful to have an understanding of how the different roles connect to one another, so that later when you specialize, you know how to work with other people that have different specializations.
Yes, precisely. The more you understand about the other roles that are not yours, the better it is to collaborate. Faster or easier it is.
Okay, thank you to the two of you. I've shared the poll results. Actually, interestingly, most identify as a data scientist, but then there's a very large group that clicked other. I don't know if you're willing to, but if some of those that clicked other were willing to in the chat say what the other means, that'd be actually really interesting to see. Because it's such a large number, maybe we're missing something. And then many of you are looking for a first role, or thank you, just interested. Most in Germany, but also worldwide. And then the final question, actually, that was for us out of curiosity, whether you're a guild member yet or not. But so we have a lot of people that identify as data scientists at the moment, but are here nevertheless probably also to learn about the difference between data scientist and data engineer. And then we have a comment here from Arvind. I'm a professional working at Amazon. I really want to shift to AI, or especially to machine learning. I'm not from Europe and would really like to come to Europe for job opportunities. I can answer that one, I suppose. So Arvind, if you are based outside of Europe, but working for Amazon, then there's only two ways actually probably in which this can go. Either you can transfer with Amazon. This is a rather well-known way of doing things. So you transfer with the company that you're already working for to a new location. Otherwise, for Europe, what you would need is you would need a special type of visa that allows you to search for a job. Yeah, so it's a job search visa, and you can Google that for yourself. That will give you the answer. Okay, and then from SY, what would you advise to someone who has done data scientist work during his whole career in academia, but is facing difficulties to be considered as one and to pass the cut of recruiters or recruiting? So this is somebody who's been in academia for a long time. Dania, Ellen?
So I've not spent that much time in academia, so can only speak from the experience of friends I had. And I've had friends who were in that situation, and usually the issue was with the way they were wording their CVs. So at least, I mean, back then the job market was also a bit better. So nowadays it's probably even harder, and that has nothing to do with you because simply the job market is terrible. But I would really recommend you to find somebody who works in industry to review your CV and give you advice on how to present your experience in a way that it sounds like it's professional, not just academic. So I've seen that make a big difference to people that came straight from academia and wanted to move it into data science.
Mute myself. Should we move on, perhaps? So more specifically, whether as a career switcher you would want to start with a data analyst and then move to data scientist. My answer would be yes, often. It's the easier and faster transition typically, and it doesn't require that you know machine learning. Okay, Dania, just checking, am I on the right slide now?
I think so.
Okay, good. To everybody who's wondering, we've been working on the slide set and I made some last minute changes, and just looking at it, I'm wondering myself whether I exactly got it right. Okay, Dania, off you go.
Oh no, I think that now we should go to Ellen's slide.
So I did got it wrong. So there we are. Ellen, it's your turn.
Okay, so yeah, that is actually addressing exactly the question that, who was it? Not Erwin. I don't find the question, but Vladimir. Vladimir was asking about the specialization. So as I mentioned, I did a poll in my Twitter feed about what other data scientists would recommend to whether to specialize or not. And I was actually expecting the results to be a bit different. I was expecting more people to vote for specialized than for generalist, but it seems that, and I got some, if you could go to the next slide. I asked people for some of their reasons for why they gave those answers. And it turns out that the reason is actually that the reasons that Nia and I brought up earlier, that it's more valuable, at least in the beginning, to really understand the whole space and then figure out what's important to you. And you will probably find, because data science or data in general is still a fairly immature field, especially in Germany, that you might have to switch around between roles a lot and do things that are adjacent to your role, depending on what the team configuration and the company is, how the company is set up, and depending on what your interests are. There was, however, one fellow data engineer of mine who said that specialization is more important because, and there's a point to that, the rules are it's very different. The rules that a data analyst does is very different from what an ML engineer is doing, which is again very different from what a data engineer is doing or an AI researcher. So this probably, the ideal conclusion is probably really this T-shaped profile that Nia was that we saw already on the slides a little bit, where you start up broad and then as soon as you figure out what you want to do and what you're particularly good at, to switch into a specialization, because you will be much more valuable on the long run if you're specialized. But it's hard to move it immediately into a specialization, and maybe doesn't make too much sense. Okay. So then I wanted to introduce a little bit about what's cool about data engineering in particular. So for those of you who are considering that role, here are a few indicators that I found are indicators that data engineering could be a really cool career for you. And so the first thing is that you enjoy coding more than modeling and analysis, because data engineering is all about writing code. It's really a specialization of software engineering. So coding is super important. And you also like to think about the quality of your code. That's one of the main differences I found, for instance, between data scientists and data engineers, or also machine learning engineers, that because data engineers and machine learning engineers write production code, the quality of the code is really important. And there are people that enjoy worrying about these details, and like myself, and there are people who don't enjoy worrying about these things, and they just want to write prototypes that might break, and they're more interested in what they're doing with the code rather than the quality of the code itself. And also, if you find that the technology that you work is more intriguing to you than the mathematics behind it. That was for me the biggest reason why I left data science again, because I'm not really that into mathematics. And I found that I don't really enjoy digging too deep into linear algebra and calculus and all these things. While I understand a lot of this, it's just not enjoyable to me. Another big difference between what I found between data science and engineering is that in engineering in general, you're likely to work in much bigger team setups. And especially you're more likely to work with team colleagues very closely, because the engineering systems that you build are always more complicated than just the prototypes that you build as a data scientist, or the models that you build as a data scientist. This is changing, of course, as more data science moves into production. There's also more collaboration, but I found the collaboration is more intense in engineering. And also, that's also a preference of me. I prefer to be closer to the technology than to the business and the product. And that's really, to me, is really the important distinction. If you really enjoy figuring out business problems or optimizing products, then you're probably better off in as a data analyst or a data scientist. And if you really prefer more the technology side and find it more interesting, then you're better off as a machine learning or data engineer. And finally, if you really enjoy building things that work and figuring also out why things don't work, which often, I find a lot of people enjoy building things that work, but then don't necessarily figuring out why they don't work. But as an engineer, that's a lot of your time is spent on figuring out why things are broken and fixing them. So, which I personally find super enjoyable. For me, it's like a detective story. So if these are some of the indicators that could show you that data engineering is a good fit for you.
Okay, Ellen, I have some questions that came in the meantime.
Mm-hmm. Sure.
The first one, Tad, asks, hi, Ellen, if you studied an information systems degree that doesn't necessarily focus on computer science principle, but just basics, what could you currently do to switch to data engineering? I'm a junior SQL developer and done the Udacity data engineering nano degree.
Yeah, it is indeed hard to find junior data engineering roles because a lot of times in companies, data engineers are still the first data engineers right now, and they're looking for somebody who can establish teams. But what you can do to is really to focus a lot on what in information systems often is a bit missing is the software engineering part. So if you can either do another online course or just do your own project where you focus a lot on software engineering. So it doesn't even have to be data systems, but just build software and figure out, and also read books like Clean Code, which is kind of the Bible of people that care about code quality, and other things that learn about software architecture, software design. There's a lot of things you can do in your spare time. And just you probably have friends somewhere in computer science, or you can find people on meetups that you can just do things together with and figure out. So you have some company and some people to work with, because as I mentioned, the collaboration aspect is super important for engineers.
Ellen, I have a follow-up for you from James about the similarities or differences between data engineering and machine learning engineering.
A lot of it is similar. So both of them are specializations kind of software engineering. The only difference is so I'd say there's an overlap of probably 50 to 60%, but the technology is different. Whereas as a data engineer, you work a lot with distributed systems, with databases, with data processing frameworks. As a machine learning engineer, you work more with machine learning tooling, with machine learning infrastructure, machine learning workflow tools, and all these kind of things. So there's a heavy overlap, but the focus of the specialization is a bit different. Okay, but I've seen people, sorry yes. to interrupt you. I've seen people switch over pretty fluidly between data engineering and machine learning engineering, as long as they have an understanding of machine learning and data. Then I've seen people cross between those quite a bit.
Thank you, Ellen. Somebody is just checking the name of the book. It was Clean Code, no?
Yeah, I can also type it into the chat.
Yes, so actually, if you go on your search engine and you look for the book called Clean Code, you'll get it.
Yeah, exactly.
Oh, exactly. Okay. Dania, would you also like to say something about data engineering, ML engineering, and how you see that?
Yes, I agree with Ellen. And I would add that usually the data engineer is there before working with the data scientists and figuring out a model. And after that, there's going to be the deployment of the model, and then more relevant to work with machine learning infrastructure and the workflow. And that's when the machine learning engineer role comes up. That might be one of the reasons why a data engineer could move fluidly to the role of machine learning engineer.
Okay, thank you. There's another question by Aravind about the must-have resume skills for data science. Aravind, if that's okay, I would like to postpone, because I know that Dania and Ellen are going to end up there precisely, and then you would get the picture of that. If I return to the slide set and click on the next one, you see that we've sort of entered the first round. So Dania, Ellen, any final observations from you on the different roles? Ellen's shaking her head and it's fine. Shall I continue? So now we're on the right slide. Okay, Dania, over to you to explain the T-shape.
Yes, so what I have here is the T-shaped skills, and we have on the horizontal across discipline. So I try to concentrate in 5 verticals for different skills. So you can think about different disciplines. The first one is the domain expertise. The second column is visualization and communication skills. The third one is programming and tools. Then we have machine learning algorithms and statistics. And the last column here is software engineering and different platforms. So this is again about the generalist versus specialist. And the generalist would be covering a lot of those 5 different verticals. And when we talk about the specialist, it's because you choose one to go deep, so in the vertical. And then for each of the different 5 roles that we have been talking about, there's a different distribution and deepness for the disciplines. Yeah. So we can go to the first one, please. Okay, so I started with the data engineer, and I would very much like to hear Ellen's feedback on this. So I am a data scientist, and you will realize that as we move forward with those slides, because I have some understanding of the other roles, but I am not acting as a data engineer or data analyst, so I have an understanding that is kind of basic. So what I understand of the data engineer is that there are 2 main focuses. One is on the programming and tools side. So I try to put some examples, programming languages like SQL, Bash, Java, Scala, Python, and some of the tools, they are all related to data processing and distributed systems. So for example, Hadoop and different databases. Then we also have Git for version control, Docker, Airflow, and Jenkins. The second discipline that I am focusing on is software engineering and platforms. So there, for example, we are talking about data pipelines, different data structures, and the platforms like Linux, AWS, Google Cloud Platform, Microsoft Azure, a lot of cloud platforms we have there. Yeah, I just want to say, before we move forward, for all of those examples here, I am focusing on the more of the stronger ones for each of the roles. It doesn't mean that you don't need any of the others. Of course, the more you have of the others, the more of a complete professional you are. But I would say those are the main focus. Okay,
thank you, Dania. Yes, I'm going to press, and because we go over to Ellen. So Ellen, what you now saw is one of those slides that I had to amend in the last 10 minutes before we got going. So I appreciate you also saw it for the first time. If you want to go back to it, let me know. Otherwise, it's your turn again to take us through the next slides. So on getting started, please.
Yeah, so I think somebody was also asking how to get started in data engineering. And to me, there are 4 technical skill areas in data engineering. And in order of importance, there are first of all software engineering foundations, then data modeling and analysis, which may come a bit of a surprise because it doesn't sound that engineering heavy. But it's actually really, I found it's really important to understand that because we're working so heavily with data, to understand what the data actually is, why it's structured the way, where it's coming from. Especially because when we talk about data quality, and when we talk about structuring and data architecture, it's really important to be able to analyze the data and model the data into the structures that we want. Then the other really important one is the cloud infrastructure and operation, because most of data engineering these days is on either AWS or Google Cloud or Azure. It's very rare. You still see companies that have that run their own Hadoop clusters, but those are increasingly rare, and they're usually moving away from it, unless they have some very high specific security restrictions, for example, sometimes to keep them. And only the 4th skill level that I think is important is actually the one that you associate most with data engineering and that you may often find as the most prominent in job description, but I think it's actually the least important one. That is the big data technologies or distributed data system, which are all the buzzwords like Spark, Flink, Hadoop, Kafka, etc. And why I think these are least important is because A, they keep changing. B, a lot of data engineering is actually not so much about big data. It's more about a lot of data sets, a lot of small data sets and combining them together. And it's also often more about complex data than about big data, because very few companies actually have the scale of data that justifies investing in some of these big data technologies. And also they keep changing. And once you understand the basics of software engineering and the data and the cloud infrastructure, it's often easy enough to pick them up, not in all detail, but in the level of detail that you need. That's why I would really recommend to start with software engineering, which is the one that's least likely to change. And also the most foundational one, because while you may not find it necessarily in job description, as soon as you have a job, you will be much more appreciated if you know actually how to write good software and write clear code.
Ellen, I have a question coming in for you on the cloud infrastructure. So this is about specialization, one of the service providers or not. Yeah. Is it sensible to specialize in AWS or Azure or all of them, or how do you handle that?
So I would say it's not necessary to specialize because they're all very similar and they try to often imitate each other. So if you know one of them, they all work kind of alike. And also you don't need to know them in the same level of detail as an infrastructure engineer will do. And you will usually work together with an infrastructure engineer who is specialized on the topic. So I would say having an understanding of their principles and having some experience with any of them is really helpful. But you don't need to know all of them, and it's also not, because you never know which, at the company you're working, which infrastructure they use. So I wouldn't specialize myself too deeply, especially in my first role, to one platform or the other.
Okay, thank you. Should I move on to the next slide?
Sure. Yeah, that's a general advice about how to get started. So I wrote a whole Twitter thread once about exactly this question, how to get started in data engineering. And one of the core conclusions was that it really helps, because data engineering is very hands-on, to start with projects or project-based tutorials. So rather than, say, buying a book, they're really good books on data engineering, but they will be really hard to get started with, and they're more helpful once you understand the basics. So the best way I found to get started is to define yourself some small projects or take a project like classes or tutorial, like for instance the nano degree that I think Todd mentioned. And so just learn your skills hands-on. It also gives you the chance then to build a portfolio, so you can put something on your GitHub account and something to talk about in interviews, which is always really helpful. Even if the project does not turn out to be precisely what you'll be doing in the future, probably it won't. It still gives you something cool to start off to think about how to build software.
I just want to add curious topic is I saw this thread on Twitter, and Ellen also shared some of those insights on LinkedIn, and that's why I had the idea to invite her to be our guest today. I thought, I mean, this is amazing. We can talk even more about this and put it in a different format. So thanks for joining, Ellen, and for sharing all of this with us.
Yes,
You're
indeed.
welcome.
So for the participants, you can click on the link in the slide if you like. But the other thing I'm going to do is I'm going to wrap up the slides as a PDF and send them out to you tomorrow. So you'll get all of this, and then you can go through this at your leisure. And I also looked at the thread on Twitter, and I highly recommend it. Yes, so slides are coming, Matthew. Next, it's still your turn, Ellen. The crucial skills and concepts.
Yeah, the slide looks very different, much better than what I put in. That's why I was confused for a second, but yeah.
I have a little anecdote for you and the participants. You know, I've been switching between various tools to do these kinds of slides, right? And over the past 5 months, I've moved back to Microsoft. And the reason is actually that what you can do, there's a little AI that now powers the PowerPoint. And you can put in lists, and they give you the slides. So really all I did is I took your words and typed them or copy pasted them, put some bullet points in front of them, and this was the result. So I didn't do any of it.
Amazing. That's a really good tip. I still have PowerPoint sitting around somewhere as well. I should give it another try. Yeah. Cool. So yeah, and since I recommended to start with software engineering, these are, I think, some of the crucial things you should know if you want to become a software engineer. Especially these are easy to learn with projects. So the most important thing, in my opinion, is testing. So understanding, making sure that your test actually works. Then version control is super crucial. If you ever make changes to your code, or if you want to work together with others, then this is the one thing you really need. The other topic I already mentioned, which is clean code. So code that other people can understand and maintain, and also you can come back to in 3 months and still figure out what you were doing back then. Which, especially when you're a beginner, is often not the case, and you look at your old uni projects and you're wondering what on earth you did there. Then when you move into production code, 2 other things are super important, which is deploying. So usually these days you don't just put your code on a server and it runs, which we still used to do 15 years ago when I was starting out. But nowadays you build up a deployment pipeline with something like Jenkins, for example. And so understanding how to set up an automatic deployment is super useful. And you can do this with GitHub as well. There's a built-in GitHub actions which help you deploy your code. So that's something really cool to play around with. And also a bit overlooked sometimes, but really important, is to monitor and log to figure out if something goes wrong, which goes back to this point I mentioned earlier, that most of the time of software engineers is actually spent figuring out what went wrong rather than making things work. And so that monitoring and logging really helps you to figure out what is going wrong, and learning how to do that well is super useful. And then, of course, as a junior, the last two are less important, but the more experience you get, the more important they become, which is how to design software systems and how to architect large software systems, especially in a distributed context.
Okay, next one.
Mm-hmm. Yeah, is there more coming?
Yes.
Okay. Right, this slide. Yeah, so that is just kind of like a wrap up. So why I think software engineering is so super important, because really it's about the standards and quality we are expected to deliver, because data engineers, just like machine learning engineers and other software engineers, we build production software, and we are expected to we are held to by the same standards as other production software engineers, because as soon as it's a production system, your customers and your clients will not be thrilled at all if it breaks. As soon as you don't want to have your issues and your concerns found by your customers, you want to find them before they hit the customer. And that's why all these software engineering principles are super important.
I agree. I once had a colleague who quit, who said, you know what, I'm leaving. I'm so sick of the maintenance of a bug-ridden system, I'm going. So indeed. Are there any more? So I would like to have some more questions from the participants, please, on data engineering, and to Ellen, if you like, while I press forward. And we're going to slightly switch. So Dania, it's back to you.
Yes. Again, going back to the T-shape skills, and now talking about the data analyst role. So here I have a lot of emphasis on the machine learning algorithm and statistics, and mostly on the statistics for descriptive statistics, hypothesis testing, probability distributions, and regression. I think those are the most important statistical tools for the data analyst. Combine that with the domain expertise. So if you are a marketing analyst, or if you're working in a specific industry like mobility, you are going to combine that. And the tools you're going to use for visualization and communication. So Excel, Tableau, maybe you are programming in R or Python, and you have there some visualization libraries you can use. You use SQL to access the data from the database. And also in the communication part, you work a lot with data interpretation, and you must have a logical approach. So as I said before, it's more like telling a story with the data, when you can connect that to most likely some question from business, some hypothesis. And the next one, maybe data science. Machine learning engineer. Okay, so the machine learning engineer, difference with the data engineer here, I added a bit more of knowledge in the machine learning algorithm side. So having an understanding on how the libraries for machine learning works, for example, scikit-learn or MLlib, that is pretty useful. And on the software engineering side, it's really about deploying it. So any knowledge about microservices, about machine learning infrastructure is also very important. And the next, please. Yes, then it's the data scientist. So comparing to the data analysts, again, we start with the domain expertise. So having some understanding on the industry that you're working. You also have some visualization and communication skills. Here I have examples in both Python or R. So I don't think that you need to know both, but one of those. So I put there some examples of libraries for visualization in Python would be matplotlib and Seaborn. In R, we have Shiny, we have ggplot2. Then it's even more important to understand the programming languages. So besides getting the data in SQL and knowing some bash scripting, knowing either R, Scala, or Python to program your machine learning solution. And the tools you're going to use, if it's Python, most likely it's JupyterLab or Jupyter Notebooks. If it's R, then RStudio. Together with, again, Git for version control, Docker, Airflow, and Jenkins when you are thinking about deploying them. But the biggest or the strongest discipline for the data scientist role is really the machine learning algorithms and the statistics one. So again, I have 3 examples in Python, some of the libraries there, or in R, some of the libraries, and again, machine learn MLlib, which is the Spark library for machine learning. So for example, for Python, what we have there is some data manipulation libraries like NumPy, Pandas, again, visualization with Matplotlib, and then the machine learning ones like scikit-learn and Keras for deep learning. Then depends on which of the machine learning algorithms you're working with. So for example, for time series, you can use Profet from Facebook. If you're doing NLP, you can work with NLTK or Genzim and so on. So there you would have very specific libraries, the same in R, you have very specific libraries depending which kind of problems you're trying to solve. And having the knowledge of the cloud platforms, there is also interesting because if you want to, you can use some of the machine learning strategies or machine learning services that the cloud offers. So some of them, especially I have been working with AWS, so I know that AWS has a lot of implementations on their side that you can use, so it could be interesting.
Okay,
that's it.
That's it. So there's some questions coming in that we will answer first, and actually I would like to go back to this and also have Ellen's opinion on this. So the first question from Julia is, does anybody still work with Starter?
I haven't heard of it.
Ellen, any chance you know anybody who still works with Starter?
I do, but they're all either in economic institutions, so like economic research institutions, or in academia. So it seems to be very specifically for economists that work with Starter. And if you're close to economic research, you might get into Starter, but apart from that, I haven't seen it personally. Not in industry, at least.
Not in industry, exactly. And then we have a question about from P. If you have one advice for someone who looks for their first role, what would that be? And then it says in order to decrease their chances to get a job. I'm assuming you meant increase, but actually it'd be interesting to look at those two things. So what is the one thing that you could do to increase your chance to get your first role? And what would be the one thing you could do to actually decrease it? Dania, would you like to start?
No, I'm thinking about this interesting change of perspective.
Yes.
To decrease the chance to get a job. Well, if we think about this idea of data science being a team sport and that we have different specialized roles in the same team, I think to decrease your chance to get a job is not knowing how to work in a team, not knowing how to collaborate. And it's not only about, let's say, the soft skills or communication skills, but when we think about programming, is what Ellen mentioned very strongly, is having knowing how to use version control, for example. So, and this is something that could happen, especially when you're working by yourself in your project in academia, that you collaborate with you, basically. So this is a very important skill to learn, and it's super useful. I mean, if you don't have it, it's the first thing you should look for, or you will have to learn it on the job. So if you want to decrease your chance to get a job, you don't know Git, something like that.
Okay. Ellen, you have a comment?
Yeah, the collaboration is definitely a strong one. And then the other thing I think is not be willing to learn anything new, because as a data scientist or in any data role, because the field is so new, and especially as a beginner, you won't know everything. So showing and not just telling people that you're eager to learn, but really having evidence that you're really good at learning and that you can figure things out by yourself will make you more employable, in my opinion.
Yes, I super agree with that, especially also because technology is changing so fast. We always have new technologies, we have new algorithms, new implementations, so you have to keep learning.
Okay, thank you. I have more job market questions coming in. from Vladimir and from Sergio. There's some common things that people put on their CV that is a red flag for an employer. And then the other one is the unicorn search, even for data analyst roles. And how does one handle this unicorn problem? Perhaps a bit more on the, so I'll give you a moment to think, actually, because there's perhaps something I could contribute here, since I've also worked particularly with CVs. So red flag for, so what you can do to help yourself, and what on the other hand perhaps is critical. So I think what helps on your CV and when you're searching, and also for handling the unicorn problem, is if you have a sense of where you're going. So if you are able actually in 2 to 3 sentences to say who you are, what you do, what your strong suit is, and what you're looking for, what you're actually looking for, where you would want to contribute, yeah, where you're headed, that really makes it easier for an employer, human resources or hiring manager, doesn't matter, to kind of look at your profile and understand that you're headed in a direction, and that it's their direction, or that it's at least close enough to their direction, and therefore they should be interested. And then when it comes to the skills or the experience that you have, the more specific you are, the more you can talk by example and perhaps quantify your example and make it relevant to where you want to go. That helps. And then the other way around, what's really, really difficult is actually if your CV mirrors the unicorn problem. And a CV that, to my mind, mirrors the unicorn problem is a CV that sort of shows general enthusiasm, or perhaps even says, I'm an AI enthusiast, to which I guess most hiring managers will go, oh, yuck, shikes, no, please not. Yeah, so when you stay very general, when it's not clear what specifically you want to contribute to and what really gets your interest. So, and specific can be that you know that you want to work in finance, or you want to work for a consultancy firm, or it's got to be mobility, or it's got to be health. That already helps. Then the next thing that helps is if you know, for example, if you're dealing with data, whether you're more attracted to stuff to do with text as an NLP, or you're more about images, or you like time series or something. So there's perhaps a particular approach that also helps the company to understand that you're doing something or interested in something that's particularly relevant for them. Yeah? So the more specific this gets, the better, and the more generalist you stay, the more you think you might look like a unicorn, or perhaps you're thinking you're keeping your options open, but actually the problem is that nobody will want to approach you because they can't nail what it is that you're looking for, and therefore that makes it hard. Okay, now long speech, enough said. Ellen or Dania, can you add to this, or would you like to?
Yes, I agree. I agree with you, Chris, because that's the thing. When you're trying to please everyone, you are not pleasing one person, so it gets harder.
Yeah, it goes even further than that, and that is the misspecialization. So say you're specialized in something, but it's okay not to like what you're specialized in and realize that it wasn't the things you're doing. But if that's the case, if you want to say switch from energy into music technology, for example, that's perfectly fine. But if you don't state the obvious fact that you're switching from a field, and you don't know what's happening in music technology, what methods they're using, etc., and how does your previous experience, how is that the right flag? So, if anything that shows that you didn't figure out A, what the company and the role is about that you're applying to, and B, what your own strengths are, is definitely a red flag. So if you say, are really good at analyzing chemical structures with machine learning models, but now you're applying for a recommendation systems team, and it's not clear what you can bring to this recommendation systems team, it might be really you're probably not going to be the first one to be invited.
Yeah, especially when you're transitioning, it's important to put explicitly what are the transferable skills.
Okay, thank you. So we have another one from Tad that brings us back to the similarities and differences. So how hard is it to switch from data engineering to data science, or perhaps back again? So Ellen, you actually did that in a way. You switched from software engineering to data science to data engineering. How did that go for you?
Yeah, it's a really interesting question. I think I switched from data engineering to data science 4 years ago. And I think the situation was much easier back then because there weren't as many data scientists around with specialized backgrounds. So at the time, the fact that I knew some machine learning and some statistics and some other relevant skills actually made me employable as a data scientist. And also I switched in the same company, which made a big difference because people already knew me and they trusted me and they knew my desires and my experiences, that I had spent some of my time on my own to learn relevant skills. So I think if you nowadays, especially if you don't have the background in, say, that Jania pointed out here, especially around ML and statistics, it's very difficult. But if you bring that and you just say, if you have an academic background, say in machine learning and statistics, and you still want to try out data engineering, then I think it's easier to switch. But if you don't have that background, then it might be really difficult.
Anya?
I think it also depends on the setup of the team you're working with. So I think it's also easier to switch from one to the other when you are in the same company. Mm-hmm. And I think a lot of the opportunities will rise depending on the other people in your team, because in the end, what you want to do is complement each other. So let's say, even if you start with peers that are in the same cross-discipline with you, but you want to specialize in one of them, it might be easier to get the title changed, for example, to data engineer or to data scientist. Because then if you are in a team, then people can go in different verticals, specializing in different verticals. And this is somehow what I saw happen already. Everyone starts as a generalist data scientist, but then after some time, some people are taking more care about the system, so they become data engineers. Others are taking more care on the business side and working with stakeholders, so they become data analysts.
Okay, so there's another question from Matthew. Matthew, before we go there, I would like to ask actually a question to help perhaps clarify some of these diagrams that we've been looking at. So Dania, and perhaps Ellen, you can also comment. Looking at the red one here, which is the data scientist, I noticed quite a lot of arrows. And I also noticed 2 arrows that are going deep, and there's a lot of tools, library, skills listed here. If I perhaps go back to this one, or perhaps go back to this one, it kind of looks much cleaner or less cluttered. Yes. Or is it less? So can you comment, do you think that the data scientist is more of an all-rounder, or that they have to have the most, or what's going on here? Why is the red so much and the yellow not so much?
Yeah, I think that is from the historical reasons that Ellen already mentioned. So everyone was a data scientist, and then the specialized roles started to emerge. But it also has to do because I wrote the slides, and I am a data scientist from back of some years. So I started, so I studied applied math. Mm-hmm. So I am really strong in the machine learning, algorithms, statistics, linear algebra vertical. And then I did a master's, even in applied math graduation, we learned a bit programming. So, but then after I did a master's in computer science, where I became more, comfortable, let's say, with programming and using the tools. But yeah, then when I got my first job, I was a marketing analyst. So I had to learn a lot about marketing and a lot about communication and visualization. Because if I wouldn't be able to do that first part, I also wouldn't have the chance to do the machine learning algorithms. So it was trying to sell this data literacy or getting used to looking at the numbers, so then I could dive deeper into the models. And more recently, when we talk about really deploying these models and serve them to the customers, so for example, working with recommendation on e-commerce, when you want to show the people browsing the website what are the products you recommend, you really need to learn a lot of software engineering, and you need to learn a lot of the cloud platforms where you're deploying your model. So yeah, if you have someone that is taking care about that, you don't need to know that much. Just an understanding that it exists and how you can work together is fine. That's why the arrows are less deep.
If I may comment on this, I think what happened here is a little bit that I think the the roles are not depicted at the same level of seniority. Because also what Dania just pointed out is she acquired a lot of skills by now, but we could probably proportionally scale all these errors, because I think the point that Dania captures here really well is that data scientists are more generalist in general than most of the other roles. But maybe because of that, they don't need all of these knowledge in the same level of depth especially as an entry level data scientist. You probably don't need them at the full level of depth yet that they're depicted here. So I would say this is more the senior data scientists from the profile, and whereas the other ones are more the entry level.
Interesting. Okay. Okay. So for the participants that are watching this, these are actually some of the new slides that I was working with lately today. Thank you for your comments, Ellen. Also, thank you for elaborating on this, Tanya. So if you have more questions on this, yes, so Sergio wants to know how you moved from being a marketing analyst to a data scientist.
Okay, so from my understanding, so this was 2012, and the data scientist brand was just starting to come up. So what I was doing in as a marketing analyst was, besides looking at the data in descriptive ways, I was already working with churn models and propensity models and clustering of customers, which is now what is called data science in marketing. So I think it was more of a rebranding of the job title than really changing the tasks. Then I specialized in, or for my master, I specialized in recommendation systems. And then it really made sense that I worked as a data scientist, because the recommender system needs to be deployed in the website, or they need to go live. Different than clustering, for example, for customers, that you can do it with, let's say, less than live data. So it's possible to freeze your database and paint their set for the customers, or for the different clusters of customers you have. But when it's about recommendation and you really want to provide something that it's updated during the browsing time on the website, you need to go live. I think that's when it made more sense to be on the role of data scientist. So that's how it was for me.
Thank you. There's some more questions on the labor market that we perhaps take. And I'm going to try and stick them together and say something to them and give you a chance also to reflect on this, because there's this question from Vladimir, which is about the COVID situation, COVID-19, corona pandemic situation, and how does that affect the job market, and perhaps what you observe at the moment, including then from Matthew, the question, how long does it take to be job ready at the moment as a data analyst or data scientist? And probably they go together, because it's changed how you look at this. And so something that I've noticed, and that probably everybody has noticed, is simply that we've moved, for data roles, we've moved back into a buyer's market. With the buyer's market, I mean that because of the pandemic, short-time work, hiring freezes, and so on, at the moment, actually, there are much more applicants than there are jobs, in a way. Yeah, so we have a buyer's market, and the companies get to be a lot more picky. Yeah, so it's not, so to speak, that generally speaking, there's now suddenly a huge oversupply of experts, but given the way the labor market is organized at the moment, it's just how it is, and we have a buyer's market. And that obviously affects also the question how to get job ready and how to get a first role, and how to do this. I don't know how Dania or Ellen see this, but if I think about it for a moment, I'm thinking that when I see data analyst or data scientist, so I'm simply aware that, you know, and Dania made this clear through her slides, that if you think about a role as a data analyst, depending on where you come from, it may simply be easier to slot into it, because you don't have to go all the way to learning machine learning models in the first instance, typically. And I'm also guessing that this is going to pick up, and I'm also guessing that given the fact that the corona pandemic and what we're doing tonight, we're all in home office, we're all all much more digital and producing much more digital data that somebody else can use, that actually in this field of data things will move, and that perhaps they will first move in fields that where lots of companies now suddenly have needs. Yeah, so to my mind, somehow data scientists, data engineering, ML is kind of at the deep end, and there's a way in which a lot of companies do data analytics that isn't not necessarily at the shallow end, but that's simpler. And that, if anything, this is where I would advise to go and look first at the moment. Ellen, how do you see that?
So I don't have great insight into the labor market, but my perception is that because what, as Chris mentioned, is more of a bias market, unfortunately, seniority expectations have grown a lot. So whereas maybe a year ago, it was still possible in a sensible time to find a junior role, nowadays, because there's simply also more senior people available, those are the first ones to get picked. And I would expect that this is across the board. But what I've also been hearing, and I'm not sure if it's still the case after COVID, but it was definitely, from what I heard, it was definitely the case before COVID, that the demand is slightly shifting more from the generalist role to the specialist roles. It's especially to the engineering, machine learning engineer, and data engineers seem to be in higher demand right now. It's as general data science. Probably a lot of it is a rebranding, because these people used to be hired as data scientists, and now companies realize that they actually need more specialists in these roles, and that's why they're looking for these engineers that didn't exist a few years ago.
Yeah, that makes a lot of sense, Ellen, especially because when you mentioned the 4 skills for the data engineer, and the first one is really software engineer foundations. So maybe companies also realize that they could tap into those people that already have the foundation and want to develop more on the data side. That opens up a lot of possibilities for both the companies and the people looking for a position.
Okay, thank you. We would move on, I guess, to the final section, unless there are more questions coming in. I have to do something unusual. I apologize to everybody. But while we were speaking, my daughter came in. So here you go, Corona home office. And when she left, one moment. Maya, kannst du die Tür zumachen? Okay, problem sorted. So this was my daughter Maya that opened the door and now closed it again, making sure there's not too much background noise. So I'm going to run through the final part. While I do that, if anybody still has questions for Dania or Ellen, or generally on the topic, please have them. What I'm now going to do is we've been getting questions on the labor market, so I'm shifting a bit there in terms of orientation, what one can do. So first up is this stuff on market orientation. And something I would want to point out here is, if you look at this slide, it looks at different industries that are dealing with data and trying to do things in the machine learning space. And I found this relatively interesting, because if you look at the, you have the 2 axes, and the one looks at the return on investment, and the other one looks at the investment volume, actually. And it gives you a quick impression about where things are moving and where they're particularly interesting. And I wanted to point you to the quadrant about the high AI investment and the high returns. Also point out that if you look at the life sciences and the healthcares, there's high investment, but the returns take longer. I would take low returns here simply as it takes longer. So there are things going on there. And if you're now looking on the labor market and you're looking to move, or you're looking at a first role, I think this is relevant for you, because it simply shows you in which areas the expectations and the data kind of match, that things are moving. And then I would expect people in the quadrant with a high return, so perhaps lower investment but high return, or high investment and high return, to move again faster and to be hiring sooner and more, if that's of help to anybody. Then the next thing to point out is to say that if you do this, and Ellen already alluded to this, we're in Europe. It's early days overall, but in Europe, Europe isn't quite where California is, if you so like. So there's certain kinds of challenges that have been reported again and again, and we have simply summarized them here for you. So there's, in the first instance, a challenge around data volume, accessibility, and quality. Then there's a challenge around the trust of customers, stakeholders, and employees, and then a challenge around the competence. And this is interesting because if you look at these challenges here, they are not challenges around modeling. They're not necessarily challenges around technical skills. There are, and Dania and Ellen can probably confirm that also, of course, challenges around deployment and getting the thing into production and getting some continuity done. But if you look at this here, the challenges are in some sense earlier and more basic. Yeah. So also if you go for interviews or you're looking for a next job and you're wondering where companies are and also what kind of questions to ask. Yeah. So asking them really about what's going on with their data, whether it's accessible, how much have they got, how they handle it, and so on, is really interesting to you, because then you're not in this position, I got hired as a data scientist and where the heck is the data? Yeah, so do this, and then also to be sensitive or attentive to this question of where the company is in terms of building trust. It says here customers, but it also says stakeholders and employees. So I once participated in designing a training for machine learning for a large German corporate, and it was actually specifically designed to give lots of employees, well, lots, yeah, a few dozen employees experience with machine learning and what it can do, because indeed internal resistance in the sense of, you know, is this any good? Can we do this? What's the benefit of it? And is also still there. So this is something to pay attention to. I was talking about industry, but startups have the same challenge sometimes. Yeah. So data volume, accessibility, and quality equally. Then of course, how well the company is funded. So, you know, this if you go for a startup, that it doesn't go out of business in the next 3 months. And then particularly for startups also, we had this with the number of employees, the expertise level, and the team size, so that you pay attention to the fact that there are some senior people on board and the team is large enough. Okay, so much. I have another question coming in. So from P, you all understand the importance of personal projects. Would you look, so if you were to decide to hire, how important to you are the personal projects of the candidate? Actually, I would like to give that to the two of you, Dania and Ellen. What have you seen in hiring processes?
At least to me, because I've mentioned this point a lot, it's less about what is in the project, but more the way you talk about it. So it will impress me if you have anything on your CV that indicates that you worked on your own on it. But more importantly, I would ask you in your interview about, and then I would be interested in, how did you decide which problem to take? How did you pick the data? How did you prepare the data? Did you have some thoughts? Did you give some thoughts about which algorithms you used? And so it would, the project itself can be anything. It's really, but it's really about how you approach it. Is the code well written? Did you think about how you organize your codes? All these kind of questions would be really important to me. And do expect that if you have a project on your CV that you will be asked about it.
Yes, that's very true. And I agree that it's not about the final outcome of the project, but really about the journey. So how did you approach it, or why did you want to do that? And when you set your mind that I want to tackle this problem, or I want to dive deep into this data set and see what I can do, then you start thinking about the practical issues that you find out, or you have to find practical solutions for it. And this is what we do like daily in a job. So it's very interesting when you have that some of that experience already.
Okay, great, thank you. So, and actually, I also remember from the slides that we're looking at that Ellen specifically mentioned this, yeah, start with projects. If you have, also if you have a GitHub that actually has reproducible and clean code, that helps. This kind of stuff. Okay, moving on. So I spoke, you know, I showed you a map that kind of looked at the investment landscape and suggested that in certain quadrants, companies are perhaps seeing greater benefits and therefore are more likely to hire. We looked at some of the challenges, and I now have for you a startup market map. So the point of this market map actually for you is in the sense of orientation again, to kind of look at it and understand, grasp how the market is moving fairly quickly. And what's really relevant here is that you see certain kinds of categories like conversational AI or auto or core AI or text analysis and so on. And I present this to you as an idea of how to understand which categories they are, also to figure out whether they relate to you, whether you're interested in them, whether you have matching skills, and in this sense, perhaps to check up some of the companies that are in there to then check whether what you're seeing in the market map in relation to yourself is working, and to use this also to start having better answers to the question of where you want to go and what you're really interested in, where your contribution would be. And to use this or other market maps precisely to do that kind of stuff. While I'm talking, and before we go to the next section, back to the questions. So Vladimir wants to know more about the projects. Is it just enough to give a link to GitHub, or should one actually describe the project in the CV? Dania, Ellen, you have any?
Yes, I have an answer to that. And I would say it depends on how much other experience you have. If you have relevant work experience, and you have a lot of it, then don't put then mentioning the name of the project is probably enough. But if that is your main experience in that field, then describe it as as relevant as you can. I probably don't write a novel about them, but give it a paragraph even where you say, I did this because of that, and that's how I approached this. So it really depends on how much space you have on your CV and how prominent you want to showcase this as opposed to your previous work experience, depending on what is more relevant.
Anya? You nod? Okay.
Yes, makes sense.
Makes sense. Yes. So I would also tend to agree, and I have an example from some of the work that I've done. So in running stuff around science to data science, particularly with PhD students, I've noticed that if PhD students or postdocs go and describe their PhD or postdoc in some detail as a data project on the CV, this is really, really interesting to employers and hiring managers. And the way to think about this is they don't want to know the details of your research, and they aren't that interested in the first instance in the scientific outcome. Yes, of course, you can mention publications, but what they're interested in is that you tell the story of how you handled the data, what kind of data with it, for whom the data was useful, what you did with it, and so on, because there's a way in which you can talk about your data competence and what you achieved with this. Yeah? And this actually makes a difference. And I'm imagining that with the GitHub, it's pretty much the same. So if you really did something interesting, it's all right to speak about this. And then Dania, we have a question about the AI Guild. I'm guessing, yes, of course, we accept non-European residents. So the AI Guild got started in Berlin, and it does have a European focus, but we're not limited to that, right?
Yes, yeah. Please join wherever you are.
Wherever you are, exactly. Aravind wants to know, do companies search for international talents? This is, so to speak, the question of international mobility. So it's a difficult topic, but Dania, you actually have some personal experience with this also at the moment. I think international mobility at the moment is simply really, really difficult because you don't even know whether your plane will take off. I'm reminded of somebody I spoke to. He's actually German, but his fiancée is from Canada, and she's stuck in New Zealand at the moment, and she can't move. And that's how bad it is. That's how bad it is, yeah.
Yeah, at the moment it is challenging, but in general, there are a lot of opportunities, at least here in Berlin. Yes,
the opportunities are there, but mobility at the moment is very hard. And so.
But I think another good side of this pandemic and working from home being more accepted, or people really adapting to it, is that it might be possible to start remotely, for example.
Yes, that's a great idea. I was just going to say that if anything, I would at the moment look at the remote labor market. I think that's
because we know that this is temporary.
Yeah,
this is temporary.
However, the remote, sorry.
Yes, go on.
Remote opportunities are even more overrun. I know that from people who are applying to them, that even if they have really strong profiles, they usually get rejected on the first. Simply because because the labor market for remote positions is so completely overrun because everybody is applying to them that simply they just reject en masse. So if you can avoid that, I would not, especially as a junior, I would not expose myself to that.
Okay. So this is because too many people want to work from the beach, yeah?
Probably, or they want to work for a company that is famous. And now is moving to remote, say Shopify or Twitter. Of course, everybody wants to work for them, and so everybody applies.
Okay,
yeah.
Understood.
And then you don't have the local applications, you have now world applications coming in.
Yes, yes, okay. Tad wants to know about the German. No, so in other contexts, we've shown that the professional language for most of these things is the same that we're using tonight. So English. However, whenever you swap countries, if you want to stay and remain, it does help to learn the local language, at least to what I like to call the dinner speaking level. So that you can hold your own. I've also moved in my life to different countries, and I've always found that it's much more enjoyable, not just only much better, but much more enjoyable when you get there. Okay, so, and if anybody's interested in the AI Guild, I'll type this in here. You just simply go to the website where you can find the rest. And then we can go back to the slides perhaps and run through this. So I wanted to give you a bit more background information using, as you probably noticed, other people's data, so to speak, on what to do with the labor market and how to move. So what you have here is a slide that is looking at the United States, actually early AI adopters more specifically, so companies that to some extent know a bit more what they're doing. There you can see that it's simply relatively broad, yeah. So from people that have technical skills all the way to people that have more domain experience, including project managers in the middle and transformation experts. So there's a whole set of skills that aren't just technical that are needed, and therefore also a wider variety of roles. If you then move to Europe, here we're looking at corporate Europe. Then you can see that technical skills indeed is a large blue column, but right and left of it are two others. So skills interfacing with AI, that's all the people that have roles that benefit or contribute to doing kinds of things around product, can be around business, can be in a particular domain. So if you, for example, are trying to improve the way the marketing department is working, then in the marketing department, you need some people who understand what's going on with AI so that they understand what the value and relevance is. So it's a very broad move that is occurring there. And then here I've taken a slide showing this for German industry, where you can actually see, I don't know whether you remember this, but it was kind of interesting. So for the early adopters in the United States, it was more clearly that they wanted technical people. If you looking at Germany, then you understand that this is a much broader spectrum, and that some of the people that they actually need in the sense of change management or transformation experts have a really broad skill set and perhaps are not technical people at all. They're just trying to help the company to transition from A to B to be more data driven, and there's still a lot of work to be done. And then another one here that also shows you this again, that it's often very basic, yeah. So it says here in German, Verständnis über Einsatzmöglichkeiten. So this is just a general understanding about the possibilities and also the limits of deploying data analytics, machine learning, AI, and what have you. So it can be relatively fundamental. And I'm mentioning this also here because, again, tonight in the discussion, we had people that are looking for a first role or looking at a second role and are looking to transition into the field. One of the ways in which you could look at this is if you're here tonight, very likely you have some technical skills, but it could be really interesting to combine these technical skills with something else that is company oriented or business oriented in the sense of change management or in the sense of product and so on and so on. And this might also move you forward. Okay, I'm going to come to the last round in the sense of AI use cases. So more specifically, we looked more generally at the market orientation. Then I looked at what's missing for, what employers are missing in a way. So what kind of gaps they actually have. And then I would move now in the final round to some of the use cases in more detail where this is headed. And then I'm looking at my screen because there's a question coming in. Are there established companies in the market that are only now adhering to data science ML? What are the opportunities in these companies? Ha! Ellen, how do you see that? I mean, you also work in a consultancy firm, so presumably you have some corporate clients. Where are they?
Yeah, it's a really interesting question. So yes, there's a bunch of companies that are only now, especially in the German more traditional industries, that are only now getting interested in AI or in data topics in general. Where are they? So they're often in a, so often they have one specific thing where they're using AI, one specific one, the one use case within the entire company that they're doing really well, and then they're still trying to find the second use case or maybe the third use case. So there's a lot of experimentation and a lot of figuring things out, and a lot of these change and transformation and understanding what even the opportunities are is still going on. So they know that there's a potential, and they may have one or two things in production that they actually use, and then now it's the mystery of how to move on from that.
Okay. So it's actually identifying the opportunities and then making them work.
Exactly. That's a big part of what I see to be a need right now.
Yeah. Yes. So, I mean, actually going back here, you're getting the slide set, and you see here the source at the bottom, right? And you can then follow this up, and you will find that, for example, in this study, there's more relevant data that they've put together in some nice charts that you can glance at that basically confirm what Ellen was just saying, that when you look at corporate, and this is not just corporate Germany, this is corporate Europe. Yeah. So it's very much early days, and most companies have managed to have implemented it in one function, perhaps two, and then that's it. There's hardly a company that is data driven already. Okay, so moving on to this use case question. So what you see here again is data among the early adopters in the United States, and then where are they? And interestingly, or perhaps unsurprisingly, the top 3 AI use cases focus on something that's already connected to IT, so automation, quality control, and cybersecurity. And then as you go down the list, you see a few more. These are sort of general use cases. Yeah, they're not specific yet to a particular industry. So you have particular analytics or risk management, and all the way down to marketing optimization. But the list kind of gives you an idea about where, for the more advanced players in the United States, things are happening mainly. If you then again look among players in Germany as making the European case, you can see that if you then will compare, you will see there are some differences. So sorry, this way around. So the second here is actually IoT. And if you go back to the United States, you see that this isn't so prominent. And these kinds of slides hopefully give you some information about, depending on which labor market you're looking at, and particularly if you're looking at the German and or European one, what might be different here and what it might help you in the sense of orientation of where to go. And then if you again look at some more European indications to the German ones, where are they looking for? You can see actually here at the very top one really is data analytics. And it's not necessary, so we already had that, yeah, so to speak, the deep end versus the more immediate ready way of using data to improve your decision making. And actually this is the number 1. And then the number 2 is process automation. And number 3 is chatbot. And this is very interesting, and as far as I can tell, also really very real. Yeah. So if you're actively looking, data analytics is by far the biggest field at the moment where it's most likely, and if not that, it's about process automation. And process automation also, there's a reason for this. Yeah. So process automation is almost always internal to a company. That means if you make a mistake, it's bad, but you're not doing it in front of the customer, at least not necessarily in front of the customer. Yeah? So it's easier to do that in a way. And also, of course, what is going on here is if you're automating processes, what you're trying to do is you're trying to bring costs down. Yeah, you're trying to simplify, bring costs down, make savings, and so on and so on. So this is also an obvious thing. And even behind the chatbots, actually, hiding behind the chatbots, cool technology, but hiding behind the chatbots is again the same thing. So I give you as an example, us being in Germany, as you know, there are very many automotive companies around here, and those that actually produce cars and sell cars, of course, have something that is called the after-sales market, and the after-sales market for them is very lucrative. So this is actually, so to speak, once you've bought the car, everything else that they can then still sell you, including the service. But this is typically very labor intensive and also very face time intensive until now. And here comes the chatbot. Really, it's actually about bringing down costs of these services and making them more lucrative. So even behind the chatbots is very often this question of optimization. And I think it's interesting to pay attention to that if you're handling here. Okay, so I was going to wrap up at this point, then give back to Dania and Ellen for final comments, and to you for some final questions. So from what you've seen now, keep observing the market. You're getting the slide sets. There are some sources there where you can get more information if you like. And then, so to speak, as how to go about this, look for matches between employers' need and your skills profile. So when we do our CV or when we're looking for jobs, we very often kind of look at our own life, and it's called curriculum vitae also, so to speak, for a reason. So one looks at what one has done, what kind of strengths one has, and so on and so on. But you could, for a moment, reverse engineer, if you so like, try and put yourself through the data that you have here in the shoes of an employer and ask what are actually their needs, what is it that they most want or need, and if you get through that a little bit, you will find that your chances improve a lot, because you can then start matching your skills profile to what they're looking for. And I think that would be helpful. And then the final comment is, while you're doing that, please be aware that there are some sectors of the industry that are bigger and moving better, and some that aren't moving that well. And this, depending on where you're looking or what you're looking for, may also impact how you move forward, whether it's for a first, a second, or a third role. Ellen, perhaps over to you first. Any final observations on where we're heading?
Where we're heading? Yeah, I think there was I don't think I have too much to add, actually. I think the summary of that, we're still in very early stages, and that we're heading more into professionalization of data science, and that's why also into more specialization is definitely a really valid point. And also, but specialization, and that's maybe the thing I want to add, doesn't mean you have to be a data engineer for the rest of your life. That's not what I have been, and I don't think anybody needs to be that. There's perfectly a chance to move around if you keep your eyes open and you realize your interests are shifting. You can always switch to an adjacent role if you keep learning and if you keep exploring. So these specializations are kind of like archetypes, and they're useful in that sense, but they're also not like this. You shouldn't look at them as a prison cell or a box to check off.
Thank you, Ellen. Dania?
Yeah, I agree that we are evolving these definitions or the specializations. And for now, what we have these archetypes, but the thing is that what we see still in the industry is a lot of blurry definitions. So we don't expect you to find such crisp job descriptions or job roles, but at least if you have this in mind, I think it can be very helpful to guide you in your career. So you can start thinking about the T-shape again. You can start being broad, and then with experience, depending on looking out for the opportunities you have in the team for shifting and so on, you can become specialized. But as Ellen said, I couldn't agree more. It's very possible to take advantage that it's still early stages and change between roles until you figure out where you want to stay.
Thank you, Dania.
So,
so the benefit to the early days, so to speak, is that it's more fluid and flexible, and you can try yourself out. I also overall think that the field will grow. Exactly. I've noticed that we are finishing on the dot. So it's 7:30. We promised we'd be done by 7:30, and we are done. We already have the thank you coming in. So thank you from our side as well. Thank you for joining us. We hope you've enjoyed it. We'll probably do this again. Let you know via Eventbrite. Thanks for being here. Enjoy the evening. Good night. Thank you.
Thank you for joining. Thank you, Ellen, for being our guest today. A lot of insightful things.
Thanks for having me.
Thank you, Ellen.
Thanks everyone for being around.
Thank you and good night.
Bye.
Bye.